All right, the last section we have is over arguments. An argument consists of two parts. There is the premises, which is the given statements, and the conclusion, the result determined by the truth of the premises. A valid argument occurs when the conclusion is true, whenever the premises are assumed to be true. An invalid argument is also called a fallacy. So what we're going to do is we're going to be given an argument. We are going to analyze the argument by assuming everything we've been given, all the premises, are true. And we're going to determine whether the conclusion could also be true by assuming that everything else we've been given was also true. If the conclusion is true, assuming everything we were previously given is true, then we have a valid argument. If the conclusion is false or indeterminable, then we have an invalid argument. So we have a couple of simple examples of arguments first. So we're going to underline the premises with one line and the conclusion with two lines. And we're going to determine whether the argument is valid or invalid. These ones we're not going to do a whole lot of mathematical looking at. We're just going to think about it. So the first argument says, all pigs are pink. I am pink. Therefore, I am a pig. So the premises are that all pigs are pink and I am pink. The conclusion is that therefore I am a pig. I have reached the conclusion that because my skin is pink and pig skin is pink, I am a pig. This would be an invalid argument. I am not a pig. I might eat like a pig sometimes, but I'm not actually a pig. Just because my skin is pink doesn't mean I'm a pig. Okay, the second one. All of the teachers at CCD received a 3% raise this year. My friend is a teacher at CCD, so she must have gotten a raise. So the argument, all of the teachers at CCD received a 3% raise this year, and my friend is a teacher at CCD. Conclusion, she must have gotten a raise. If all the teachers at CCD got a raise, and she is one of those teachers, then she got a raise. This is a valid argument. She's part of that all. Most people who live in California are Democrats. Mike lives in California, so he must be a Democrat. So most people who live in California are Democrats. Mike lives in California is our premises. Our conclusion is that he must be a Democrat. This one is invalid because it doesn't say all the people that live there are Democrats. Mike could be part of the people that are not most people. Most people is not all the people. So we cannot conclude that just because Mike lives in California, that makes him a Democrat. If it rains, I will need an umbrella. I don't need my umbrella, so it must not be raining. This one is valid. All right, my screen's not moving. Hang on. There we go. All right, so Now we're going to get into a little bit more complex of examples. So for each of these, what we're going to do is we're going to continue what we were doing where we underline all the premises with one line and the conclusion with two. Then in the box next to it, we're going to translate what we have in words into symbols. And then we're going to use the techniques that we learned with truth values and multiplying and adding and the equivalent statement that we learned. And we're going to determine whether there is truth to this argument or not. So we are going to start with this first one, which says, actually, I'm going to start with the second one. The first one is, I need to move it, but I'm going to start with the second one. So I'm actually going to start with B, not A. I don't like A. So B, if it is cold, my motorcycle will not start. My motorcycle started, therefore it is not cold. The 3 dots mean therefore. So my premises are, if it is cold, my motorcycle will not start. My motorcycle started, and the conclusion is that it is not cold. So I want to go ahead and assign P's and Q's to each of these statements. So if it is cold is going to be P. My motorcycle will not start. I'm going to call that not Q because it has the word not in it. My motorcycle started. That's the opposite of what I see above in my motorcycle will not start. So that's going to be Q. And then it is not cold. That's the opposite of what I see above that I labeled P. P is it is cold. It is not cold. So this would be not P. So all I've done is I've determined what would be P and Q in what I've been given. So now over here on the right-hand side, I'm going to rewrite everything in this symbolic form. So if it is cold, my motorcycle will not start. So I have an if-then statement. If it is cold, then my motorcycle will not start. So that's P, arrow, not Q. I'm going to go down a little bit in here, and I'm going to write down the Q. And then I have the 3 dots and the not P. I like to do the 3 dots on the side as well, just so that I know that that last line there, that's my conclusion. All right, now what we're going to do first is we're going to get rid of this if-then statement. Okay, I don't like dealing with if-then statements, and we have an equivalent statement for that. Recall, we have P, then Q, can be written equivalently as not P or Q. We negate the first piece, we change the second piece to an or, and then we leave the third piece as it was. So I'm going to rewrite this first term up here as not P or not Q. And then this if-then statement goes away. So I'm going to cross it out because I rewrote it as an or statement. I can do math with or statements to determine whether they are true or false. I can't do math with if-then statements to determine whether they are true or false. All right, so now, in order to determine whether we have a valid argument or not, we have to assume that our premises are true. So I'm going to assume that Q is a true statement, and I'm going to assume that this entire OR statement is true, not the individual terms. I don't know about the individual terms, but the entire OR statement is true. So basically, each sentence I was given in my premises, I'm assuming is true. And because the first sentence was made up of two simple statements, I don't know whether those simple statements are true or not. All I know is that the combination of them is true. But the second sentence I had, my motorcycle started, that is true on its own because he's by himself. So each line here I'm assuming is true. So now, if Q is true, and I come up here and I look at this Q, this is not Q. So Q is true, so that means not Q would be false because it's the opposite. Let's do this in this color. So not Q would be false. I have an OR statement here, so that means addition. And then I have this not P. And the only other place that I have a not P is down here in the conclusion. I'm going to separate that conclusion with a line, just so that I can see that he's totally separate from everything else that I'm doing. So I don't know what this not P is. So I've just put a box there for right now. So I have an unknown plus a false statement, and that needs to equal a true statement. So I'm going to look at how I could get there. I'm going to look at the two possible ways that not P could be. Not P could be true or it could be false. So if not P is true, not P would be a 1 plus a false statement is 0. 1 plus 0 equals 1. 1 represents a true statement. And that's what we want to end up with. So that's good. But what if not P is false? Does it still work out to be a true statement? If not P is false, that would be 0 plus 0. And that's 0, which would be a false statement. So the only way for not P or not Q to be as a whole true is if not P is true. Not P has to be true in order for the entire statement to be true. This has to be true. Because if they're both false, then the statement is false. But we know the statement has to be true. So not P is true. If this not P is true, this is also not P. It's the same thing. So not P is true, which means not P is true. This is our conclusion down here. So not P is true, and that's our conclusion. So because our conclusion is true, this is a valid argument. The person's motorcycle started, so it's not cold out. And we proved it mathematically. Let's look at C. Going through the same process again. You must eat well, or you will not be healthy. I eat well, therefore I am healthy. So I have you must eat well, or you will not be healthy. I eat well, therefore I am healthy. So you must eat well is P. You will not be healthy. I'm going to call not Q because I have the word not in the statement. I eat well. I eat well. You must eat well. Those are the same. They're saying the person is eating well. So that's P. Therefore, I am healthy. That's the opposite of not being healthy. So that's going to be Q. So now off to the right here, I'm going to go ahead and write out what I have here symbolically. So I have P or not Q. I have P, and then my conclusion is Q. And I'm going to draw a line to separate it. I'm going to pull this right down a little bit more. All right, we don't have to do an equivalent statement because we don't have an if-then statement. We have an or statement, and that's what we want. So I'm going to go ahead and say, okay, I'm going to say this is true, and this entire or statement is true. Because we want to assume our premises are true. So if P is true, then this P must also be true. Because they're the same thing. And then or, I'm going to write this just a little bit lower. Or means addition. So I have this not Q that I have to figure out. So that this whole statement equals a true statement. Okay, I'm going to make this just a little bit thinner. So if not Q is true, what would this sentence look like? We would have true plus true. So true plus true, which would be 1 plus 1, which equals 2. A statement is true if its value is 1 or higher. So this would be a true statement. So not Q could be true. Could not Q be false? Let's just try that letter again. What if it's false? We have a true statement in P plus a false statement in not Q. So that's 1 plus 0, and that's 1, which is also a true statement. So is it true or is it false? Well, the answer is, I don't know. I cannot tell you whether it is true or false. And because I don't know what not Q is supposed to be, because there wasn't a clear answer like there was in the previous problem. In the previous problem, we were able to say the only way that this could be true is if not P is true. But in this case, this statement could be true regardless of whether or not Q is true or false. It could be either, and I could not tell you what the answer is. I don't know what the answer is. I don't know if not Q is true or if it's false. I don't know. So because I don't know what not Q is, I can't tell you what Q is supposed to be down in the conclusion. The only way I could figure out Q is if I could figure out not Q. But I can't figure out not Q. Because both ways of looking at it lead me to true statements. And that's not very helpful. So because I get to a point where I can't get to an answer, I have an invalid statement. The only way the statement is valid is if your conclusion is true. If you don't have an answer to the conclusion, it's invalid. We'll look at another one. If a metro rail system is not in operation, there are traffic delays. Over the past year, there have been no traffic delays. Therefore, over the past year, a metro rail system has been in operation. So our statements, our premises. If a metro rail system is not in operation, there are traffic delays. Over the past year, there have been no traffic delays. Therefore, over the past year, a metro rail system has been in operation. That's our conclusion. So it gets 2 lines. 2 very wavy lines. So if a metro rail system is not in operation, so that's going to be not P, there are traffic delays. Q. Over the past year, there have been no traffic delays. There are traffic delays, no traffic delays. Not Q. Over the past year, a metro rail system has been in operation. A metro rail system is not in operation. A metro rail system has been in operation. So this is going to be P. So we have another, if a metro rail system is not in operation, then there are traffic delays. So this is not P, then Q. And then not Q is the second sentence. And then we have therefore P. And I like to separate it. You do not have to draw this line to separate it, but I really like to because it just helps me to see that that's separate from what I'm doing up here. So we have an if-then statement again. So we need to write out its equivalence. So remember, negate the first term, change the arrow to an or, and leave the third term as you saw it. So if not P, then Q is equivalent to P or Q. And then I'm going to cross this guy out so that I know that I'm not looking at him anymore. So now I'm going to assume that my entire or statement is true and that my not Q is true. These statements are true. if not Q is true, then Q has to be false because they're opposite. We are using addition, and we don't know what P is, but we do know that this entire statement has to be true. So we're going to look at the possibilities for P. If P is true, we would have true plus false, which is 1 plus 0, which is 1, which is a true statement. So P could be true. But let's see if P could be false, because as we just saw, if P can also be false, then we've run into a problem. So if P is false, what happens? Then we have false plus false, which is 0 plus 0, which is 0. And that's false. So P cannot be false, because if P is false, then our entire OR statement does not end up being true. So in order for this entire statement to be true, we need P to be true. If P is true, then this P down here must also be true, because they're both P. They're the same symbol. So our conclusion is true. Therefore, the argument is valid. Okay, I'm going to skip E, but I will post the filled in notes so that you can look at it. I think F is a good one. Or I'm just looking at what we have on here as options. I is a very hard one. I'm not going to do that one in the video. I will post it with the notes. Let's actually do G. If all people obey the law, then no jails are needed. Some people do not obey the law, therefore some jails are needed. So if all people obey the law, then no jails are needed. Some people do not obey the law, therefore some jails are needed. So P, no jails are needed, that's going to be not Q. Some people do not obey the law, that's the opposite of P. Some jails are needed, that's the opposite of Q. So again, I have an if then. I have P, then not Q. Not P, therefore Q. Okay, here we go. Let's try that line one more time. Okay. So we have an if then we need to write out the equivalent statement for. So negate the first statement, change the then or the arrow to an or, and leave the second statement as we saw it. And then cross this out so that we don't look at it anymore, so we're not confused at what we've got. So then this is going to be true, and all of this is going to be true. So not P is true. That means coming up here, not P is true. And then I have or, which is addition, and not Q is what I need to figure out so that the entire statement is true. So if not Q is true, what does this look like? Well, we have a true plus a true, which is 1 plus 1, and that equals 2. So that entire statement is true. If not Q is false, what does this look like? True plus false. 1 plus 0, which is 1. So it's still true even if not Q is false. So no matter what I put for not Q, I could still end up with a true statement. That doesn't help me determine what not Q is. So I'm left with a question mark. I can't determine not Q. If I can't determine not Q, then I can't determine Q. And I'm left with an invalid argument. Okay, what I want to do with the rest of these is I will go ahead and post these notes completed. The best way for you guys to learn this is to just try it. Get into some of these incomplete problems that I didn't do and try and work it out. I have office hours. There's tutoring through the Excel Zone. This last one, is very challenging. You will not see anything like I. If you can get I, then you have no worries. If you can't get I, then also don't worry because you're not going to see anything quite that tricky. Okay, so there's quite a few in here that I didn't do in this video, and that's because I want you to try and see if you can do these on your own and go to my completed notes and come back to it and see if you can get answers that match mine. I don't want to do all of these in the video, but I will post the rest of these answers and these notes to our course page so that you can come back and look at them and see if your answers match mine. Hopefully this is making sense. This is probably the weirdest thing to teach without being in a classroom of any kind. But please come to office hours if you need more assistance with this. And I will stop scrolling. I will just sit right here. Okay. Anyways, that's it. That is all the material for this semester. You're done.